The cat that broke reality. Imagine a sealed box sitting on a table. Inside it, there is a cat. Also inside the box, there is a tiny amount of radioactive material, a Geiger counter, a vial of poison, and a simple mechanism. If a single atom decays, the Geiger counter detects it. The mechanism triggers. The poison is released, and the cat dies. If no decay happens, nothing is released, and the cat stays alive. The box is completely closed. No one can see inside. Now here's the question that changed physics forever. Before you open the box, is the cat alive or dead? This is not a joke, and it's not a philosophical trick. According to quantum mechanics, the answer is deeply unsettling. Until the box is opened and an observation is made, the cat is considered to be both alive and dead at the same time. A superposition of states! Two mutually exclusive realities existing simultaneously. This idea is known as Schrödinger's cat, one of the most famous thought experiments ever created. It sounds absurd, almost comical, but it was designed to expose something far more disturbing. The strange logic of the quantum world does not stay confined to atoms and particles. If taken seriously, it seems to leak into everyday reality. Erwin Schrödinger proposed this thought experiment in 1935, not to defend quantum mechanics, but to criticize it. He wanted to show how ridiculous the theory becomes when applied beyond microscopic systems. And yet, nearly a century later, physicists still debate what the cat really represents. To understand why this paradox exists at all, we need to step back and look at how quantum mechanics describes reality. At the smallest scales, particles do not behave like solid objects. They behave like probabilities. A particle does not have a definite position or state until it is measured. Instead, it exists as a wave of possibilities. This is not speculation. It has been experimentally confirmed countless times. Electrons can be in multiple states at once. Photons can pass through two slits simultaneously. Reality, at its core, seems undecided until someone looks. The problem is scale. Quantum effects are obvious for tiny particles, but we never see cats that are both alive and dead. Somewhere between the atom and the animal, something seems to break. Schrödinger's cat forces us to confront that boundary. As you listen, ask yourself this. Is a paradox telling us something profound about reality? Or is it revealing a flaw in how we interpret quantum mechanics? And if observation plays such a central role, what exactly counts as an observer? If this kind of question fascinates you, take a moment to like the video. It helps more curious minds find content like this. And keep listening, because the deeper we go, the stranger this paradox becomes. Superposition, observation, and the problem of measurement. At the heart of Schrödinger's cat lies a concept called superposition. In quantum mechanics, superposition means that a system can exist in multiple states at the same time. A particle can spin up and spin down simultaneously. An atom can decay and not decay at once. Mathematically, this works beautifully. Quantum equations describe superpositions with incredible precision. The predictions match experiments with astonishing accuracy. But interpretation is where everything falls apart. When a measurement occurs, the superposition appears to collapse into a single outcome. The particle is found in one state, not many. This sudden transition is known as wave function collapse. And here's the problem. Quantum mechanics does not explain how or why this collapse happens. It simply says that it does. This is called the measurement problem. And Schrödinger's cat is its most vivid illustration. Inside the box, the radioactive atom exists in a superposition of decayed and not decayed. The mechanism linked to it also exists in a superposition. The poison is both released and not released. And logically, the cat becomes both alive and dead. But the moment you open the box, you see only one outcome: alive or dead. Never both. So what caused the collapse? Was it the act of observation? The interaction with light? The consciousness of the observer? Or did the cat somehow collapse the wave function by being a living system? Some interpretations suggest that consciousness plays a fundamental role. The universe, in this view, remains in a blur of probabilities until a conscious observer forces reality to choose. This idea is deeply controversial, but it refuses to disappear. Other interpretations argue that collapse is not real at all. According to the many worlds interpretation, the wave function never collapses. Instead, every possible outcome happens, each in its own branching universe. In one universe, you open the box and find a live cat. In another, you find a dead one. Both are real. You just experience one branch. This interpretation removes the need for collapse, but at a heavy cost. It implies an unimaginably vast number of parallel realities constantly splitting apart. Schrödinger's! Cat doesn't die or live. Reality itself fractured. Pause for a moment and think about that. If every quantum event creates new universes, then the world you experience is just one thin slice of an infinite structure. Does that solve the paradox? Or does it make reality even more incomprehensible? If you're finding this explanation intriguing so far, consider subscribing to the channel. Parax explores paradoxes like this every week, and each one challenges how we think about the world in a different way. But we're not done yet, because Schrödinger's cat raises an even deeper question. Is the cat really the problem? Or is our intuition about reality the thing that fails? Why we never see quantum cats? If quantum superposition is real and experiments confirm it is, then why don't we see it in everyday life? Why don't tables exist in multiple places at once, or people in contradictory states? The most common answer is decoherence. Decoherence occurs when a quantum system interacts with its environment. Air molecules, light, heat, and countless other particles constantly interact with macroscopic objects. These interactions destroy delicate quantum superpositions almost instantly. In practice, this means that large objects become classical very quickly. Their quantum behavior is not eliminated, but it becomes spread out and inaccessible. The system still follows quantum laws, but it appears classical to us. Schrödinger's cat, in this view, is never really in a clean superposition. The cat is interacting with its environment, with its own body, with thermal noise. The superposition collapses long before any human opens the box. This explanation is powerful, but it doesn't fully solve the paradox. Decoherence explains why we don't observe but it doesn't explain why one outcome is experienced instead of another. It hides the problem rather than resolving it. Experiments have pushed this boundary further and further. Scientists have placed molecules, tiny mirrors, and even viruses into quantum soup. Each experiment blurs the line between the quantum and classical worlds. So, the question becomes not whether Schrödinger's cat is possible in principle, but how far quantum weirdness can scale. Where exactly does reality stop being ambiguous? This paradox also forces us to question realism itself. Is the world made of definite properties that exist independently of observation? Or is reality fundamentally relational, dependent on interaction and measurement? Think about how radical that idea is. It suggests that certainty is not a basic feature of the universe. Uncertainty is. If this video is making you rethink assumptions you didn't even realize you had, that's exactly the point. Paradoxes exist not to confuse us, but to expose the limits of our understanding. Stay with me, because in the final part, we'll confront the most unsettling implication of all. Schrödinger's cats may not be about physics at all. It may be about us. What Schrödinger's cat really tells us. At its core, Schrödinger's cat is not asking whether a cat can be alive and dead. It is asking whether our theories describe reality itself, or merely our knowledge of reality. Quantum mechanics works extraordinarily well. It predicts experimental outcomes with unmatched precision. And yet, it offers no clear picture of what is actually happening behind the equations. The cat sits in that gap between calculation and meaning. Some physicists believe the paradox shows that quantum mechanics is incomplete. Others believe it shows that reality is far stranger than our intuition allows. And some believe the paradox reveals a limit to human understanding itself. There is something deeply uncomfortable about a universe that refuses to settle on a single outcome until observed. It challenges the idea of an objective world existing independently of us. It suggests that participation may be woven into the fabric of reality. Schrödinger himself was uneasy with these implications. He never intended the cat to become a mascot for quantum weirdness. He wanted it to be. Or warning. A sign that something about the theory was profoundly unresolved. And yet, here we are. Nearly 100 years later, still opening the box, still arguing about what we see. Perhaps the true power of this paradox is not in the answer it provides, but in the questions it forces us to confront. What does it mean to observe? What does it mean to exist? And how much of reality depends on the act of knowing? If you've stayed until the end, thank you. Curiosity like yours is what keeps these ideas alive. If you haven't subscribed yet, this is the perfect moment. Paradox is dedicated to exploring paradoxes, thought experiments, and impossible ideas that reshape how we see the world. For your next step, watch another paradox on the channel and see how deeply these questions connect. And if you'd like to go further, you'll find a free resource linked below that dives deeper into quantum paradoxes and the strange logic behind them. The box is open now. The question is no longer about the cat. It's about what kind of universe you believe you're living in. So where does the paradox really begin? Before we finish, let's remove all remaining confusion and explain this paradox as clearly as possible, without shortcuts and without unnecessary complexity. Schrödinger's cat only feels confusing until you see exactly where the problem begins. Everything starts with one key idea from quantum mechanics. In quantum physics, very small things, like atoms, do not have a definite state before they are observed. Before observation, an atom is not simply decayed or not decayed. According to the theory, it exists in a superposition of both states at the same time. So far, this works perfectly well at the microscopic level. Now comes the chain of logic that creates the paradox. First, a single atom determines whether it will decay or not. Second, the state of that atom directly controls a mechanism. Third, that mechanism either releases poison or does nothing. Fourth, the poison determines whether the cat lives or dies. In other words, there is a direct cause and effect chain linking the atom to the cat. If the atom decays, the mechanism activates, the poison is released, and the cat dies. If the atom does not decay, nothing happens, and the cat remains alive. Now here is where the problem appears. According to quantum mechanics, before any observation is made, the atom is in both states at once, decayed and not decayed. This is not a lack of knowledge, it is how the theory describes reality. And if the atom is in both states at the same time, then the mechanism it controls must also be in both states at the same time. If the mechanism is in both states, then the poison must be both released and not released at the same time. Following this logic all the way through, the theory seems to force us into an absurd conclusion. The cat would be alive and dead at the same time. This is exactly where the paradox is born. Our intuition immediately rejects this idea. The cat is clearly either alive or dead, whether we look inside the box or not. Schrödinger agreed with this intuition. He did not create this experiment to defend the idea of a half-alive cat. He created it to criticize an interpretation of quantum mechanics that leads to such a conclusion. So, the paradox is not really about the cat. The paradox is about applying quantum superposition to macroscopic objects. Either superposition cannot work this way at large scales, or something is missing from the theory, or we are misunderstanding what the equations are actually telling us about reality. That is why Schrödinger's cat is not a trick or a joke. It is a warning! A signal that there is a deep tension between the mathematical success of quantum mechanics and our everyday understanding of the world. If this explanation finally made the paradox click for you, then you understand it in the way Schrödinger intended. Not as a bizarre claim about reality, but as a clear demonstration of where our current explanations begin to break down. And it is exactly at those breaking points that the most interesting paradoxes are born. Don't stop here and lock the next paradox and expand your mind even further.